Okay, so I have this recording now. So we had solved this problem, 2x minus 3y equals 13, and 5x minus 4y equals 22. We got the answer, x is 2, y is negative 3. And we did this by using the elimination method. Let's try one that sort of looks like it should be a substitution method. I'm going to give you time to try this one while I take attendance. So this, and by the way, these problems that I'm doing are coming off of practice sheet 3. Every time I enter, it looks for the weekly sessions on your Blackboard account. You'll see for each chapter, I include a practice sheet. So this is practice sheet 3, which has to do with chapter 3. I have also already put on, I posted chapters weeks 4 and 5, which is chapter 4. There also is, and I'm going to be using that today when we go to that chapter, the practice sheets from that chapter as well. So these practice sheets actually come directly from the department, the math department, so they are a good indication as the type of questions you want more practice aside from the Delta math. You can always look at these, and when doing problems in a class, for a good portion of them come right off of these sheets. So it's a good idea if you want to follow along better to have a copy of those sheets in front of you. So I'm taking practice sheet 3, and this is example number 2. And again, it says solve the system, which is y equals 4x plus 12 as your first equation. And your second equation is 2x plus 3y equals negative 6. Now see if you can solve that. I would like you to try using substitution, but if you want to use a different method, that's perfectly fine as well. While you're doing that, I'm going to be taking attendance, so please listen for your name. And again, don't forget to complete the work by the test by Tuesday. Also, I found that only about 50% of the students had done the examples that were supposed to be emailed to me from September 21st. I still will accept them if you send them in. Otherwise, by next week, it's just, if you haven't sent them in by then I won't accept it, and it'll count towards your homework mark not being incomplete. Okay, Maury here. Good morning, good afternoon. Chelsea here. Ariana
Here.
Hi, how are you? Adina.
Here.
Hi, how are you? Thought I had seen you. Lachey.
Here.
Hi.
Hey.
Kava.
Here.
Hi. Terrence.
I'm here.
Oh. Karide. Karide? I think I heard you, yeah. Kizia.
I'm here.
Faith. Ethan. Isabella.
Here.
Hi. Serenity. Reggie. I see you have the answer already. Okay.
Yep.
Obviously here. And participating, thank you. I see, I have something that says iPad raising hand, so I don't know. I'll answer that as soon as I finish taking attendance. Zamia, I'm sorry, Zamia. Zamia here? Okay, Chelsea, I do see that you're here. Brandon,
Here.
hi. Michaela,
Here.
Seraphine. Marissa. Seraphine, was that you answering?
Yeah.
Okay, got you. And Marissa here? Renee?
Here.
Hi. Sky, pretty sure I saw you before. Sky here? Okay, and I see Seraphine is here. I have you, Sky. Jaden Roberts. Kennedy. Okay, Sky got you. Felicia.
Oh, I'm Felicia. I'm here.
Felicia. Why do I have that? It's what I thought it was, and then I wrote myself a note, which didn't make sense. Okay. Felicia. Got it now. And you're here. Thank you. Natalia.
Here.
Hi. Michael. Hi. Cassidy.
Here.
Hi, good. Megan.
Here.
Hi. Kalia Watson. Kalia Watson. Lauren.
Here.
Good. And Kayla Zachary. Kayla here? And I see Faith, you're here. So let me change that. Okay, I got you. Okay. If you didn't hear your name, just send me a chat and I should catch you then. Okay. Ethan, got you now. Okay. Okay, so let's work on this question now. A few people have sent me answers. And I see we're getting a few answers. Let's see what we come up as an answer. A few people have answered this. Now, to me, this is a perfect setup for doing the substitution method, because the first equation says specifically y equals 4x plus 12. It explicitly says what y is in terms of x. So in my second equation, I can take out that y and replace it with 4x plus 12. So that my equation will become 2x plus 3 times 4x plus 12 equals -6. And now I just solve this like a regular equation. I remove the parentheses. It gives me 2x plus 3 times 4x is 12x. I'm using the distributive property, and 3 times 12 is 36. I combine the like terms, the 2x and the 12x is 14x, plus the 36 equals -6. I can then bring the 36 to the other side. So I get 14x equals -42. And again, if you want, you can use your calculator for that. You don't have to do this in your head. Divide both sides by 14. And -42 divided by 14 gives you -3. So we get for x, we get -3, which means for y, we're just going to take our first equation and replace the x with -3. So it's going to be 4 times -3 plus 12, which is going to give me -12 plus 12, which ends up being equal to 0. And my answer then becomes -3 for the x, 0 for the y. Just be careful with your signs. That was the answer to that question. So we did one question using the elimination or addition method, and one question doing the substitution method. We could have also done the method called graphing, but it would have been much more work. This was usually these two methods are the most efficient and more accurate methods that unless we're told specifically to do it by graphing, these are the methods we want to use. Now, what we're going to go on to from here is we're going to talk about how to answer certain word problems, certain verbal problems by setting up a system of equations. I'm going to give you a couple to do that we're going to do today. And after we've done those, then we'll go on to chapter 4. So we're going to do a couple of word problems. Now, one type of word problem that lends itself to a system of equations could be something called just a number problem, something that has to do with numbers. For example, again, I'm using this sheet here. This is question number 7 on their practice sheet 3. I'm going to write the pertinent information on the board, and then I'm going to discuss how we set up the system of equations so we can get the right answer. So the question here asks, we have one number is 5 more than 4 times the other. That's one fact we know about these numbers. Their sum is 10. And we want to find the two numbers. So when you have a situation where there are two things, two variables, two things that are known, it's usually the easiest way to set up the system of equations. The easiest way to solve these is by setting up a system of equations. It's much easier to set up the equations than to do it as a single equation, though some of these could be solved using a single equation as well. I usually, if I have two things that I'm looking for or two things that I don't know about, there are two unknowns mentioned in the problem, then I usually go to setting up a system of equations. Once I've set up the system of equations and I solve it, it will have solved my question. Now, one of the things that's very important to do is something called setting up a legend or making a legend, which really means writing down specifically what your variables represent. Once you know what you don't just automatically go X and Y. You have to know what are you using the X for, what are you using Y for. Once you've done that, once you've cleared that in your head as to what your variables stand for, the writing of the equations becomes much easier. So let's see what we have. We're going to have one number which is 5 more than 4 times the other number. So we definitely have two things here. We have two numbers. So let's call our first number, let's call it X. You could call it anything you want. I usually use X and Y when I have a system of equations, but it could be different letters as well. Which means that my second number, we're going to be calling Y. So I've written down, I've made a legend, I've decided what my variables are and what I'm calling them. Then I slowly read each fact that I was given. So the first thing is one number, which is what we're calling X, is 5 more than 4 times the other number, which is what we're calling Y. So the X, I'm just substituting the names I've given. X is 5 more than 4 times Y. How do we write that as an equation? X, that's our first number, is, that's always our equal sign. Okay, 5 more. How do we indicate 5 more? 5 more means that you've added 5. More doesn't mean times, it means plus. 5 less means you have to subtract 5. 5 more means we're adding 5 at the end of our expression. 5 more than 4 times the other. So 4 times the Y. Now, times means obviously multiplication. So 4 times y is 4y. So my first equation that I get from the statement, one number is 5 more than 4 times the other, in algebraic terms reads x equals 4y plus 5. Notice 5 more, I put the 5 at the end. Though if you had to put it, when you're adding, it doesn't matter where you add it. So it could have been at the front. This would have said 5 less. This is where you're going to have to be very careful. That's always minus 5 at the end. So English and algebra don't always totally coincide. You have to remember how to go from the statement in regular language to the algebraic statement. Okay, this has given us our first equation, but we have 2 variables, so we need 2 equations. So we look for another fact. And the other fact we have is their sum is 10. Now we know when we use the word sum, it means we're adding. Sum is adding, difference is subtracting. Product is multiplying, quotient is dividing. So sum is the result of adding. So we're going to add our 2 variables, the x plus the y, and that's going to give us 10. And once we have a system of equations set up, we can solve it and we will find the answer to our question. Notice this looks like a good setup for substitution. In place of my second equation, for the x, I'll put 4y plus 5. So I'll do 4y plus 5 plus y equals 10. Combining the like terms gives me 4y plus y is 5y. Remember, if there's no number in front of it, it means a 1. 4 and 1 is 5y plus 5 equals 10. If I subtract 5 from both sides, that gives me 5y equals 5. And therefore, I'm dividing both sides by 5. I get that the y is equal to 1. Now, we were told to find the numbers, which means not just one of them, but both of them. So let's see if we can figure out what x is. Well, here's the statement that tells me what x is. X is 4y, so it's 4 times 1 plus 5, and 4 times 1 is 4 plus 5, so that gives me 9. So my 2 numbers that I'm looking for are 1 and 9. So is there any question about how we go about setting up this system of equations to solve the question? Okay. So that's one type of verbal problem that lends itself very nicely to being solved by a system of equations. We have 2 numbers that are somehow interacting. We have 2 variables. The 2 numbers are the 2 variables. So we use an x and a y. And again, once you have 2 variables, it means you must have 2 equations. Okay. Let's look at another type of equation, another type of question. This is a very common type of question that lends itself to a system of equations. Listen to this question. Chad sold 30 decorated sweatshirts at a craft show. By the way, if you have this sheet, it's question number 9. Okay, so he sold a total of 30 sweatshirts at a craft show. White ones cost $10 and black ones cost $15. He received a total of $390 for the shirts. How many shirts of each type did he sell? So again, let's quickly write down the important facts, because you might not have this in front of you. Chad sold a total of 30 sweatshirts. That means he had two types, black and white, and he sold, we don't know how many of each type, but we know that altogether he sold 30 of these sweatshirts. Now, there was a difference in price between the two types of shirts. The white shirts had a price of $10, and the black sweatshirts had a price of $15. And what he made altogether, the total amount of money he made on this is $390. Again, we have two different items. So we're going to have two variables. And again, this is going to set us up nicely as a system of equations. Anytime you have a question of how much two types of things cost, that always sets itself up nicely in terms of a system of equations. It doesn't have to be sweatshirts. It could be you have Coke and Pepsi, or you have somebody's going to the theater and they have two different types of tickets. Anything where the two different items do not cost the same amount. That is a very common type of system of equation type of problem. Again, we're going to take from this real life situation and try and come up with a system of equations that will fit this situation and allow us to solve for the unknowns that we're looking for. Now, again, the first thing we want to do is we want to set up what our variables are going to represent. So again, I like to call my variables X and Y. Now somebody's going to tell you, oh, let's call X black and let's call X white and Y black. That's not a good enough description. What about the black shirts are we looking for? So look very carefully at what the question is asking. That will allow you to decide what your variables represent, what your legend should be. The question is, how many black shirts were sold and how many white shirts were sold? So let's call X how many, or the number of white sweatshirts that were sold. And let Y be the number of black sweatshirts that were sold. Again, to say white sweatshirts, it could be, well, maybe the X would then stand for the price, which doesn't make sense because we know what the price is. So I'm very clear as to what my variable represents. The X is going to stand for the number of white shirts. The Y is going to stand for the number of black shirts. And now I'm going to set up my equations. So the first fact I know is that I have 30 sweatshirts, a total of 30 sweatshirts, a combination of black and white. How do I write total? Obviously, it's plus. My first equation becomes X plus Y equals 30. Notice it had nothing to do with the $10 and the $15. We didn't include that in our writing of our equations here, because the 30 has nothing to do with how much each of them cost. It's just a total of how many there were. The total between the white and the black was 30, so x plus y equals 30 was our first equation. Now, we used the first fact, now let's go to the second fact. The second fact was that how much money he made. And the money he made depends on the price of each item. So not only must we include the X's and the Y's, we also have to include the prices. The amount of money he made from white sweatshirts was X, that's how many whites there were, times 10. If he had 10 white sweatshirts, then the money he made was 10 times 10, the price times the number. So the first thing he made is 10x. That's how much he made on the white sweatshirts. On the black sweatshirts, he made 15y, because you take the number of black shirts there were, which was y, and multiply by the 15. That's what each one costs. And if you add the 10x plus the 15y, that's going to give you the total amount of money he made, which is $390. Notice the 30 had nothing to do with money. So the equation with the 30 has nothing to do with the money. But the 390 is the money, the total money. So I have to include in front of the X and Y, the price, the money involved in each of those items. And of course, now that we have this system of equations, we can solve it. Let's say we want to figure out what Y is. First, let's say we decided to get rid of the Y first. So if I want to get rid of the Y, the first equation I'm going to multiply by 15. The second equation I'm going to multiply, well, there's no number in here, so it's understood to be 1. But since both of these are positive, I'm going to have to use a negative in one of them. I don't usually put the negative in the first equation. It doesn't make a difference which you use. So my first equation is going to become negative 15x minus 15y equals, okay, so we have negative 15 times 30. I'm going to use my calculator. And that gives me negative 450. The second equation, I'm just multiplying by 1, so it doesn't change anything. It's 10x plus 15y equals 390. And when I add these two equations down, negative 15x and positive 10x gives me negative 5x. So I told you I wanted to get rid of the y, so that's what I'm doing. Negative 15y plus 15y cancels out. And now I have negative 450 plus 390. Again, I'm doing that on my calculator. That's giving me negative 60. And when I divide each side by negative 5, I get x equals negative, and a negative is positive 12. If I got a negative answer to this, I would know I had done it wrong, because you can't have a negative number of anything. Okay, in any case, my x turned out to be equal to 12. In other words, he sold 12 white sweatshirts. To figure out how many black sweatshirts he sold, I'm going to go to this original equation. In place of x, I'm putting 12. 12 plus y equals 30. And that gives me y equals 18, which means he sold 18 black sweatshirts. Again, we had two different types of things, so it it was set up using a system of equations. The first equation having to do with how many there were of the item. The second equation having to do with how much money they cost. Again, there are a lot of questions that go like this, where you have a situation where something is being sold. Two different types of items are being sold. I'm going to give you another one to try. It's not identical, but it's very similar. Listen to this question. This happens to be question number 8 on practice sheet 3. Tickets to a local movie. Okay, tickets are things that don't always have the same price. Tickets to a local movie were sold $5 for adult tickets and $3 for students. $150 tickets were sold. And the total it was sold for was $610. So a total of 150 tickets were sold, and the amount they made on those 150 tickets was $610. And we want to know how many adult tickets were sold. Okay, I'm going to give you a few minutes to try this on your own. Give you about 2 more minutes to try this. Okay, see, a couple of people already have answers. They look interesting, right? Let's see if we can work this out together. Again, there are 2 types of items here. There's adult tickets and student tickets. So it's a good setup for a system of equations. Again, let's call X how many adult tickets were sold, which will mean that Y will be how many student tickets were sold. Here's my legend. We very much specified what our variables stand for. Okay, so let's go to that first bit of information that can lend itself to a equation. That's the fact that 150 tickets were sold. Now remember, X is how many adult tickets were sold, and Y was how many student tickets were sold. So together, when we add them, that'll give us the total number of tickets sold. So therefore, X plus Y equals 150 is our first equation in the system of equation. It has nothing to do with money, so we don't include the 5 or the 3 or the 6, 10. It all has to do with money. The 150 just talks about how many tickets there are. Look, it's regardless of the price of the tickets. So my first equation becomes X plus Y equals 150. Okay, so now we go to the 610. That involves how much money was made by selling these tickets. So not only must we include the X's and the Y's, we have to do something with the price of each ticket. So what we're going to do is we're going to do 5X to get the amount of money that comes from the adult tickets. Take each price of each ticket and how many there are, plus the 3Y, that's how much money they're getting from the student tickets, and altogether that's going to give us 610. Okay, so these types of questions very often set up very similar. When you have something that has 2 items that have different prices, and you're making, and you know the total amount you're making on it, this is the setup that you get. X plus Y equals 150, 5X plus 3Y equals 610. Now, the original question was, how many adult tickets were sold? I just added this myself. So if we want to know how many adult tickets were sold, we want to figure out what X is. So the most direct way is, this is sets up for doing the elimination method. Let's eliminate the Y, because when we'll get rid of the Y, that will help us find the X. So if I want to get rid of the Y, I'm going to multiply the top equation by 3 and the bottom equation by 1. And since these are both pluses, I need one of them to be negative. As I said, I always go with the top to be the negative. I don't know why, I just do. And therefore, my top equation becomes negative 3X minus 3Y equals negative 3 times 150, which is negative 450. The bottom equation multiplying by 1 makes it really stay the same. 5x plus 3y equals 610. And when I add these two equations down, negative 3x plus 5x gives me 2x. Again, the y's are eliminated. That's what we were looking for. And the negative 450 plus the 610, easiest to do on my calculator, gives me 160. And when I divide by 2, that gives me x equals 80. I think at least 2 people came up with that answer. 80 adult tickets were sold. Again, we were asked about the adult tickets. If we wanted to figure out what the student tickets are, we could go 80 plus y equals 150, and it would give us the amount of student tickets. So it's a very similar type problem, obviously. When we always multiply each equation, let's say I decide which variable, this is for Zamia, as to how you know what to multiply by. You first look at the numbers. You decide which variables you want to get rid of. We decided we wanted to get rid of the y because they asked, the question was how many adult tickets, which was our x. In order to get rid of the y, I multiply each equation by the opposite coefficient. I wrote the top equation by 3 because of the bottom coefficient is 3. I multiply the bottom equation by 1 because the top coefficient is 1. If I were getting rid of the x's, I would have multiplied the top by x and the bottom by 1. It just multiplied by the opposite coefficient, the opposite number. That's the easiest way to not have to think too much. It might not give you the easiest numbers, but it's the easiest way to remember what to do. You don't have to do too much thinking as to, you don't have to figure out, you could do it by the common denominator, but this method is really easier. Okay, so I think we're pretty okay on this system of equations. We've now completed chapter 3. We're now going on to chapter 4. The chapter that I said is going to be called Polynomials, how to work with polynomials. Today, in the chapter, what's included in the chapter is adding, subtracting, and multiplying of polynomials. That's what we're going to be talking about today. Division of polynomials is something that we're going to have to do, but it's in the next chapter. It's in chapter 5. The rest of chapter 4 has to do with factoring. So the main thrust of this chapter is factoring, but today what we're going to remember, we're going to remind ourselves how to do the basic operations of addition, subtraction, and multiplication when we're dealing with polynomials. Now let's just talk a little bit about what do we mean when we're talking about polynomials. What is a polynomial? There are some special types of polynomials. So let's talk about that, and then how do we work with them? So number one, if you have everything in your expression connected by multiplication, for example, you have something like 3x squared y cubed. The operation involved here is all multiplication. It's 3x squared means x times y cubed, which means y times y times y. The operation being you're involved with here of the 4 basic operations is all multiplication. If everything is connected by multiplication, you have a single term. This is what's called a monomial, a single term. when you have pluses and minuses between your expressions, then you get polynomials. For example, if I have something like 2x fourth y minus 7x cubed y squared plus 4x squared y cubed. This is an example of a polynomial because there are, not everything is connected by multiplication. You have pluses and minuses. And usually when you have adding and subtracting in your expression, what you want to do is simplify by combining the like terms. Are there any like terms over here? Anybody see any like terms? And I'm glad nobody sees them because there are no like terms. These, even though these last two terms both have x's and y's, and they have exponents of 3 and 2, the x here has an exponent of 3 and the y is 2, where here is the x exponent is 2 and the y is 3. That makes them not like terms. In order to be like terms, they have to be the only thing that can be different is the coefficient, that's the number in front, but the letter parts have to be identical with the same letters and each of the letters having the same exponent. In this case, nothing could be a combined. We're left with 3 terms. When you have 3 terms, it's called a trinomial. That's a special name for a polynomial that has 3 terms. As we said, a monomial has only 1 term. An expression with exactly 2 terms is called a binomial. We know bi stands for 2, tri stands for 3, so that's easily remembered. If you have more than 3 terms, you just call it a regular standard polynomial. A polynomial means just more than 1 term, so sort of a generic term. We don't have any special terms for 4 or 5 or 6 terms in your expression. Now, what we want to talk about first is adding and subtracting of polynomials. So here's, let's say, take an example, which is right off of a former midterm. It says perform the indicated operation, and it's -8 x squared y plus 8xy squared minus 2xy plus 8 minus, so we're doing the operation of subtraction, -3x squared y minus 10xy squared plus 5xy minus 12. So we have these 2 expressions that we want to, in this case, subtract. These are each 4 terms each. When you have parentheses and there are no numbers in front of the parentheses, remember what I said, it's as if there is a 1 in front of it that you just don't see. So there's a 1 here and a 1 here. And what you want to do is remove the parentheses and combine the like terms. So if we do that, this becomes a positive 1 in front of a parentheses doesn't change anything. This stays negative 8x squared y plus 8xy squared minus 2xy equals 8. The other parentheses, the one that we're subtracting, we're multiplying by negative 1. So that becomes a plus 3x squared y, a plus 10xy squared, a minus 5xy, and a plus 12. Essentially, what a minus in front of a parentheses does is it changes all the signs of the terms inside the parentheses. And now we look for our like terms. So here we have a negative 8x squared y and a positive 3x squared y. They're identical in the letter parts. So we combine the negative 8 plus 3, we combine the coefficients. That gives me negative 5x squared y. I'm just going to put a check mark to what I've already used. The next thing I see is an 8xy squared. And there is another term with an xy squared. There's a 10xy squared. Those are like terms. 8 plus 10 is 18. So that becomes plus 18xy squared. Okay, check, check. Now we have a negative 2xy and a negative 5xy. Those are like terms. And negative 2 and negative 5 is negative 7xy. And finally, we have a positive 8 and a positive 12, which is a positive 20. Again, when you're doing this, you have to be careful with your signs and your numbers. But of course, you can use your calculator. All you have to do is to put into your calculator is the numbers in front. But remember, you can only combine like terms. This is what's called adding or subtracting of polynomials. One thing you should be aware of is that if I say, for example, take a different problem. When I say subtract 3x squared minus 5x plus 2 from 7x squared plus 2x minus 9. When I write this out, this is a question of being very careful with your language, that the language gets messed up. Zamia, I don't understand your question. You want to ask me your question before I go on? Zamia? When you're combining, let me see if I answer it properly. When you're combining like terms, you add or subtract, depending on the sign, the numbers in front. Those are called the coefficients. And then you're just left with one of them, with that number. Okay. This one, and I want you to be careful about, is where it says subtract this from this. When you write it, what goes first is the 7x squared plus 2x minus 9 minus the 3x squared minus 5x plus 2. So be very careful when you're given something in, okay. So be very careful when you're doing something like subtract this from this, that the expression after the from goes first and then the second one. Of course, now we're going to do the same thing. We're going to act as if there are ones here. this will be 7x squared plus 2x minus 9. That stays the same. And this we're multiplying by -1, so that'll be a -3x squared, a positive 5x, and a -2. Again, multiplying by -1 is essentially changing all the signs. And when I combine the like terms, there's a 7x squared and a -3x squared. 7 minus 3 gives us 4, so that's 4x squared. Then we have a positive 2x and a positive 5x, which gives us a positive 7x, and a -9 and a -2, which is -11. So my final answer is 4x squared plus 7x minus 11. Again, this is a trinomial is our answer in this case. Okay, so that's combining or adding adding and subtracting of polynomials. The process of adding and subtracting is basically the same. You just have to be careful with your signs. When you're subtracting, it's as if you're multiplying that whole thing by a -1, but after that, it's just the same process of what I call combining like terms. Okay, so I wanted to spend a few minutes talking about multiplying of first monomials, and then we'll talk about multiplying polynomials. Again, I feel that this is pretty much a review of things that you have done before. Let's just first talk about multiplying monomials. Let's say I have a -2x for y6, and we want to multiply it, and sometimes we use a dot, and sometimes we use an x, or sometimes we just enclose them in parentheses. Then want to use another x for multiplication, so I'm using the dot. Suppose I have times 4x y 3. Let's say I was multiplying these. These are two monomials. We know they're monomials because everything is connected just with multiplication. There's no pluses or minus in the middle there. And the way we multiply monomials is we first multiply the coefficients, which is the -2 and the 4. Those are the numbers in front. And then we multiply the letters by adding their exponents. So here's an x fourth and x. Now remember, if a letter doesn't have any exponent, it means that the exponent is understood to be 1. So this is a 4 and a 1. Remember, when you're multiplying, you add exponents, so that becomes x to the 5th. And the y is a 6 and a 3. When we add that, we get y to the 9th. So that's how we multiply monomials, just by multiplying the numbers together and then adding the exponents. So how do we go about multiplying polynomials? Well, first let's talk about multiplying a monomial and a polynomial. Suppose I had a question that looks like this. Suppose I have 7a cubed b times 2ab squared minus 5ab plus 3. In other words, I'm multiplying a monomial, a single term, by a trinomial. And we all know the method that we use is something called distributive, the distributive property. We're going to take every term inside the parentheses and multiply it by the monomial, the single term that's on the outside. So first I multiply the 7a third b times the 2ab squared. So 7 times 2 is 14. A third times A, remember this is a 1, so that becomes A fourth. B times B squared, again, this is 1 and 2 is B third. Now we go and repeat that, multiplying the 7AB cubed by the negative 5AB. So 7 times negative 5 is negative 35. A cubed times A is A fourth. B times B, 1 and 1 is 2, so that's B squared. And finally, we take it and multiply it by the last term. So 7 times 3 is 21. And the letters we just bring along, A cubed, B. And that's how we multiply a monomial times a trinomial or any polynomial using the distributive property. Again, don't forget that when you're multiplying the letters, you're adding their exponents. And if a letter doesn't have an exponent, it's as if there's a 1 exponent there. So I just want to do one more thing. Let's talk about multiplying binomials. And then that's what we'll take over when we come back on Tuesday. Multiplying of binomials. So let's say I have 2x minus 5 times 3x plus 2. I have two binomials that I want to multiply. And the method we use of multiplying one polynomial times another, it's not just necessarily binomials, but those are the most common, is by using the distributive property a repeated number of times. In other words, I'm going to take the 2x in the first parentheses and multiply it by everything in the
So wait, here there are no exponents then in this equation. There are no exponents, right?
I'm sorry, I'm not following you.
Like you see this equation that you just put up right now. Like there are no exponents there. So like so when it's binomials, you don't have exponents, or you do have exponents when it's binomials?
Sometimes you do, sometimes you don't.
Oh, okay.
You can have exponents sometimes. In other words, this could be a 2x cubed and a y squared. It could be more complicated. But you can, it doesn't matter how many terms you have in terms of the exponent. All you have to remember is if you don't see an exponent, that exponent is 1. Okay, so we're going to take the 2x and multiply by each term in the second parentheses. I'm going to distribute the 2x to the 3x and to the 2. So this becomes 2x times 3x, which is 6x squared. Remember, this is a 1 and a 1, so it gives you 2. Then I'm going to take the 2x and multiply it by the 2, which is going to give me 4x. After I've multiplied everything in the second parentheses by the 2x, I go back and take the second term, which is negative 5, and distribute the negative 5. Negative 5 times 3x is negative 15x. And negative 5 times 2 is negative 10. And obviously I get a total of 4 terms because I'm multiplying 2 in the first by 2 in the second. Except I'm not finished here. I then look, are there any like terms? And I see that usually, and this usually happens, the 2 middle terms usually are like terms. In this case, the 4x and the negative 15x could be combined. They give us negative 11x. So my final answer becomes 6x squared minus 11x minus 10. In other words, usually when you multiply two binomials, your answer turns out to be a trinomial. Not all the time, but in most cases. Don't forget, every term in the first parentheses times every term in the second parenthesis. As a way of remembering this, and I'm sure you've all heard this expression, we sometimes call this operation FOIL. First, outer, inner, last. What are we doing? What is FOIL telling us? First, we multiply the two first terms in the expressions. The 2x is the first in the first parentheses, the 3x is the first in the second. So we multiply the 2x times the 3x, and that gives me my 6x squared. Next, we multiply outer. Outer means the numbers that are furthest apart. In other words, there's the first one in the first parentheses and the last one in the last. These are outer. They're as far apart as you can get. The 2x times the 2, which gives us the 4x. Then we multiply the inner. The inner are the ones that are closest together, the ones that sit right next to each other, just separated by that parentheses. -5 and 3x. That gives us our -15x. And finally, last, that's the L, the two last terms in each parentheses, the -5 in the first times the 2 in the second, that gives us the -10. And again, you look for like terms. So FOIL is just a way of reminding you that you're taking every term in each parentheses and multiplying it with every term in the second parenthesis. So that's how we multiply binomials. Okay, this is where we're going to end today. I'm not giving you any further homework on Delta Math because I want you, those of you who haven't done the test yet, to make sure to do it by Tuesday. If you haven't completed any of the other homeworks, you really should be doing your homeworks. Get your homeworks. Don't leave the homeworks all for the last minute, because you will not have time to do all the homeworks that you are required to do. And a substantial part of your final grade is from the homeworks. If you, again, let me remind you, if you wanted to redo the test because you did it once and you were not happy with the mark you got and you think you can do better, then just send me an email and I will reset your test so you can take it a second time. Again, until this coming Tuesday, I will still accept the homeworks from the September 23rd video. If you didn't do them yet, it seems like about half the students did it. So if you haven't done it yet, you can still have an opportunity to do it and get credit for it. After that, I'm not going to give you, and then it's off the board already, that I'm not going to accept it anymore because I really went over it already. So that's what we're up to. I'd like you to have a nice weekend. Again, we'll have regular class this regular Zoom class on Tuesday, and we will be continuing with our study of polynomials. We're going to be spending a good part of the day doing factoring. Okay, have a nice weekend, everybody.
Bye, Professor. Have a
You
good one.
too.
Bye-bye.